Okay, so in this video what I like to do is just focus on the setup. Again, for a mixture problem, remember I told you how there's a freebie. All right, we're going to take our two unknowns and they're equal to some total, and then there's usually a strength equation. That's the name that I give it, where how strong is X? It's A times as strong. How strong is Y? It's B times as strong. And that's usually equal to some other total that's hopefully given in the problem. So that's typically how you set up a mixture problem. So we saw it set up once, and let's do it a few more times, and then we'll backtrack and actually solve them. So next word problem is we have a recent fundraiser. Non-based cheer squad collected $688 by selling t-shirts. Right, the blue pep shirt sold for 12, the red pep shirt sold for 8. If they sold a total of 64 shirts, how many of each were sold? And so you notice we have a couple of totals here. Right, 64 represents a total, whether they're blue or red, and 688 represents the amount of money. So there's pretty much your two totals. What are unknowns? Well, there's the, not the dollars. There's the number of blue shirts that were sold, and there's the number of red shirts. Okay, if you want to call them B and R, go for it, but just make sure you're clearly identifying your two unknowns. So we don't know how many blue shirts were sold, and we don't know how many red shirts were sold. So what's the freebie? Well, X plus Y, shirts plus shirts, should equal total shirts. So this equation has everything to do with the number of shirts that we have. So we have an X amount of blue shirts, we have a Y amount of red shirts, together, total. Right, we have 64 shirts altogether. How strong, how much money was generated? Well, each blue shirt was $12. So 12x represents the dollars coming from the blue shirts. We're going to add to that, well, each red shirt was $8. So 8y represents the money coming from the red shirts. Of course, how much total money did they fundraise? $688. So notice everything in the word problem is accounted for. We've handled the totals, the rates, if you would, right? $12 per blue shirt, $8 per red shirt, and we have our two unknowns, we have our two equations, everything's accounted for. So that would be our setup for that problem. So hopefully you're kind of seeing again that idea that one of our equations is free, and the other one it kind of deals with strengths. How much, how strong is X, how strong is Y, set it equal to another total. So in the next word problem, we're going to playfully talk about algebra tacos, right? They show that on their menu that tacos are 200 calories and burritos are 580. If we order 13 items and consume 5,260 calories, how many tacos and how many burritos did we get? And again, in this problem, we see a couple of totals, right? We see there was 13 total items, whether they're tacos or burritos, and there were 5,260 calories consumed. So we, again, looking ahead, we can almost see our two equations coming up. What are unknowns? Well, we can probably let X be the number of tacos, all right? And we can let Y be the number of burritos. Okay, so that's what we're asked to find, right? How many burritos and how many tacos? So there's our two unknowns. What are my two equations? Well, the first one's a freebie, right? So we're talking about the number of items. Some items were tacos, some items were burritos, and there were 13 items altogether. So X plus Y equals 13. The next amount deals with calories, right? So each taco was 200 calories. So 200X, right? How many calories came from the burrito? Well, 580, right, times Y. How many total calories? 5,260. So again, we've accounted for all our known values. We've accounted for the rates, right? So there was 580 per burrito and 200 per taco. Two unknowns, two equations. Everything's accounted for, set up. Again, a freebie and a strength equation. Classic setup for a word problem. All right, taking a look at some tougher ones. All right, so we'll solve those a little later. So the next one, we're going to put a spice together. Paprika sells for $1.30 per ounce, and cumin sells for, that's a $2.25. Let me make sure that looks nicer, per ounce. They want to create a 16-ounce blend of these two that would sell for $2 per ounce. How much of each spice would they need? So again, X would be the ounces of paprika, and Y would be the ounces of cumin. So it looks like they're going to have a little bit of a barbecue or something. All right, so there's our unknowns. Again, we have the freebie, right? So how many total ounces do we have? Well, there's an X amount of of paprika. There's a Y amount of cumin, and in total, we want 16 ounces in our blend. So ounces plus ounces equals ounces. So good to go. Now we're talking their strengths, right? So we're talking a dollar amount. So each ounce of paprika costs $1.30. So that's $1.30 times X, because we have X amount of ounces of paprika. What about the cumin? Well, it costs $2.25. So 225 times Y equals, now a common mistake for students is to write 2. But we have to be careful, right? Because we're talking about the total money generated from the paprika, the total money coming from the cumin, and it shouldn't equal, this is a rate, right? This is $2 per ounce. So we have a dollar plus dollars and dollar per ounce. So you can kind of see we're a little off unit-wise. However, we know that my final mixture is going to have 16 ounces and at $2 an ounce. So the dollars in the final mixture would be 2 times 16. So this problem was a little tougher because there was only one total given, and we kind of had to work for that other total. But my units make sense, right? Dollars coming from the paprika ounces, dollars coming from the cumin ounces should equal the dollars in my final blend. So we're good to go. All right, and again, everything's been set up. I have 2 unknowns, I have 2 equations. We're off and we're ready to solve, which we'll do later in another video. One more problem to set up. MathWorks wants to create a gas and oil mixture for chainsaws. They want a bottle of 30 fluid ounces that sells at $1.50 per ounce. If gas costs $2 per ounce and oil is $1 per ounce, how many of each do they need? Again, there's a total here, right? So we have 30 fluid ounces. Some of it is coming from gas. So we're talking ounces from the gas, and Y is the ounces from the oil. So my freebie, we're talking total ounces here. There's an X amount of gas out, there's an X amount of Y oil, and that should equal 30 altogether. So ounces plus ounces equal ounces. The next thing we're talking about a strength, right? So we want our final mixture to be $1.50 per ounce. There's 30 of them. So there's our other total. So we have to kind of work for it. So my final mixture costs $1.50. How much did the gas cost? Well, it was $2, right, per ounce. How much did the gas cost? Well, it was $1 per ounce. And so this is basically dollars. Dollars from the gas plus dollars from the oil equal the total dollars that we have altogether. Okay, so there's some good setups. We'll take a look at some others, but I think we have 5 word problems set up. So let's go back and try to solve them. We'll do that in another video because this is getting a little lengthy.